Thank you so much, Shanki. I am going to be going through today and introducing you guys to our newest service, Momento Vector Index, or MVI, as we like to call it internally. And really just want this to be a hands-on demo showing you how you can quickly get up and running to use this to enable search on top of a NoSQL database like DynamoDB. And really give you a serverless alternative to enabling search inside your services and apps today. So I'm going to go through just a couple slides, and I promise I will keep it very short as much as possible, and then dive right into the code as well. So let me. Are you all still able to see that? Okay, awesome. So I'm introducing Momento Vector Index. My name is Ellery Addington-White. I'm a founding engineer here at Momento. And we launched Momento Vector Index really to be the fastest path to production for doing a vector search at any scale, whether that just be one TPS chatbot with you playing around up to millions of TPS or concurrent users using your vector store. It's the first actually serverless index. It's as simple as index and search. So really trying to embody a similar feel to S3 or DynamoDB operationally, or our cache as well, where it's just a simple serverless service that you can get up and running and hit fully API driven. So instantly ready, instant scale, instantly ready for production, zero distractions. Really what you would expect operationally from a serverless service today. So you can do a lot more than chatbots. I really wanted to show today a demo other than a chatbot at first, just to show kind of a little more general purpose use of a vector index. Gen AI and LangChain and chatbots are all the rage right now. I'm sure everyone's seen a lot of content on the news and online around enabling chat use cases and conversational UIs into some data set, and the explosion of ChatGPT. And it is an amazing use of a vector database. And if we have some time at the end, we can go into some demos of that as well. But I think as an engineer coming into this space, for me, there's a lot happening with the chatbot and really abstracts away a lot of the vector store itself. And it's kind of hard to see what's actually happening. So with this demo, I've really tried to strip it down and show you really the primitives of what a vector index can do. So, really quickly, just our APIs for this, similar to create cache with our caching product, to create Dynamo table or S3 table or S3 bucket. It's a single API call to create a new index with our vector store. You just need an index name and then the number of dimensions for the vectors that you would like to be putting into that index. No cluster config, no availability zone configuration, replication, TLS config, auto scaling, number of nodes or size. It's all just baked in. You don't have to worry about any of that. And it's a pay-per-use model like our other services as well. And then you can add items to your vector store. And so a vector is just really an array of numbers that represent an item after you've run it through a model to get an embedding. And I'll show you an architecture diagram here in a second that will give you a little bit better of how we get these embeddings or these vectors. But it's really like the kind of the core piece to this. You run some item through a model and you will get an output of a vector. And it's a really powerful idea because when you're doing search in the past, many people have heard of like full text search or text search, and it's very specific to text. But with this abstract idea of search with a vector index, any item can be boiled down into a vector, be that some text, an image, some audio, and even like an object, a Pojo or some other object in your ecosystem. And so really going to show that today, how you can go from like an item in a database to a vector and enable a very similar text-based search but with a vector index instead. Yeah, and so the same thing, the search API, very thin, your index name, the input vector query, and then the number of results you'd like. So what are we going to be building today? I'm going to be diving in, and it's actually a continuation of a blog I published the other day, which maybe Michael or Jonky, you can drop the link to the Getting Started with Vector Search blog, where we're just showing how to build a text-like search on top of DynamoDB. And this is a problem that I've run into in the past. And usually when I've run into this problem of trying to enable some sort of basic search across a Dynamo table, my go-to tool in the past has been OpenSearch or ElasticSearch. And really trying and using that to index all of my items out of my Dynamo table and then enable more of a text-based search experience. And I actually ran into this, like, you know, I always do some freelance on the side in the past at work. And I actually had a client that was wanting to build a search capability on top of their movie catalog that they had at a movie store, which was like a very niche thing here near where I live. But I had to build this service for him. And it was like this funny little service where we had to search, and I had to end up spinning up an ElasticSearch node to actually do that search on top of Dynamo. And it was really like overkill at the time, and it was a pain to maintain. And I really wish I had something that was like fully serverless to just reach for and enable this type of functionality. And so I just kind of took that experience from my past and applied it to this demo here with building a basic movie catalog for search, where we're going to have a data set of movies, and they're actually linked to that data set in that blog. It's an open source data set of 50,000 movies, and just sort of their titles, their overview, like a description about them, so IMDb ID, a few other properties as well. But it's a pretty good open source data set just to start playing around with to enable something like this. And what we're going to do is for each of those movies, we're going to go through and first load them out of a CSV into DynamoDB just to get those items in our database. And then we'll enable a DynamoDB stream to pick up on those items and actually get the embedding for each movie. And I'm going to go into more detail on some of the details around how you get those embeddings. And then we're going to add those items into our Momento Vector Index. And so this is what I was talking about earlier, where we're going from this abstract object, which is like a movie in our database, to a vector, and then inserting it into our index to get to be indexed and then to search it. And then we're going to have a bit of a little user experience where we can search our vector store and build like a basic search bar type experience in a UI. So that was it for slides. Just trying to keep them light. Any questions on the architecture or anything else before we dive in and start looking at some code? Oh, I see we have some chats too. Okay. Awesome. Seems like we're good. Okay. So now I'm going to dive in here to some code. And similarly, I'm just going to go through this and show you kind of the core parts of the code. I've already deployed this and actually indexed some movies in my account, and I'm going to just show you what this looks like as the end experience. So the first thing we have is we're actually reading a CSV of movie data out, and we're iterating through each item, and we're putting those items into our Dynamo table. And then the other key part is our search. Actually, let me show you the index data first. So here we're reading, this is an additional functionality I made just to rip through all the items and index them immediately. So I'm just going to show you this right here, where we read the raw movie data from CSV out of S3. And we limit it to just a certain number of items right now, just for demo purposes. Because my credit card's hooked up to OpenAI, which is what we're getting the embeddings with, which I'll show you in a second. And we're going to get the embeddings for each movie and add them to a list to add to our vector index. And so for each of these items we got out of that CSV, or each movie, we're going to rip through and we're going to build up this list of items to add. And for each item, you can see the vector input for that item. We're calling this get embedding function that I wrote, and we're passing it the title of the movie and the overview of the movie right now. And so this is to enable some basic search, where if you search not only like the title of the exact title of the movie, but also maybe just something about the movie, we'll have context in there about what our movie, like different parts of our movie. So it'll allow us to get a little bit more flexible of a search. I'm using the row number as the ID for our item. And this is a really cool feature of our vector store as well, is we can add this metadata. And so I'm attaching the title and the IMDb ID as metadata to my item in my vector index. And what this will do is when we do the vector search, we'll actually be able to pull specific metadata out about each vector as we get it. So this function looks, sorry, apologies, my dog is barking as well. But this function is very small here, but it's doing a lot. So let's just dive in here, and it's really a very crucial part of this application is actually us getting those embeddings from the model. So like I mentioned, we're putting the title and the overview in as input to the embedding to actually get as input into our vector out function. So we're going to be getting a vector as the output of this. And these are the attributes of our item that we want taken into account in that vector. And so we're just actually, if we look at this get embedding function here, we're actually using OpenAI just because it's very easy to use. There's open source models as well. In that blog that we sent earlier, I'm actually using sentence transformers, which is a open source library you can use to generate embeddings as well and not have to call OpenAI, which behind the scenes, this is making an API call. But it was a little bit heavyweight for Lambda, that library. So I'm just using OpenAI's embeddings as a service. And we're using their general purpose text embedding model. And this is, for me, was kind of the light bulb moment when I was starting to play around with vector indexes. It's like they have these really awesome trained models for doing text similarity search across a large knowledge base. And you have all these items in your database. And so really, if you can just stringify your item in a database, you can get a vector representation of it, and you can put the characteristics into it that you want taken into account. And so that's really all we're doing. We're just using their off-the-shelf text embedding model from OpenAI, and we're passing that input text of title and overview in as the input to this and getting an embedding back. So that's a really important part of this, and it's something that's you can tweak and tune what model you're using in different libraries here. It's very flexible. And right now we're just offering a vector store. So any type of embedding built from any library can be used as input into our vector store. Any questions on the embedding piece? I can only see Jonky right now, so.
Yeah. A question we have is how would you add facets to this search, i.e. search for movies by category? Would you
Yeah.
encode the category ID in a different vector index and find the intersection of the items by ID?
Yeah, awesome question. So there's no like 100% correct answer here. Search can be very complicated, especially at scale when you're like, an Amazon or an Etsy or one of these big, huge search sites. And so the reality is you actually have to do a whole combo of different approaches to build to enable a really sophisticated search at scale. Like Michael mentioned in the chat, we are supporting basic filtering soon, and that'll enable facets. the other approach, we actually have a really awesome talk about this that Jonky can probably put in the chat as well from MoCon on kind of search at scale, and some of the different approaches that they take. And yeah, it's a combination of different indexes, different mixers that sit on top of the different indexers that put in business logic and lots of different strategies there. So it's a great question. We will enable a lot, but then you'll see some people making different multiple indexes for different types of data and adding in sort of just traditional business logic in and on top of that, depending on things like, so for our movie example, maybe like recommend more scary movies at night versus in the morning. So yeah, no right answer there, but it's a great question. And it's definitely probably like the next few subjects that like we launch on that blog series, we want to kind of deep dive on different approaches there. And yeah, the MoCon videos are available online. Jonky can drop the YouTube playlist for those in the channel as well. Okay, perfect. Okay, so any other questions before I dive back in? Okay.
Good.
Yep. Okay, cool. So we went through our batch index. So here we've just batch added all our items to our vector index. And now they're ready to be searched. And so let's go to the search functionality. This is going to be the next kind of key piece, is we're going to have a input query here. And so from our input query string query, that could be like dog or cat or whatever you're searching for, that's the user generated input. We're going to get embedding for the user input. And then we're going to call with our client search, and we're going to pass it that input vector as the input. And we're saying now, just give me the top 3 movies you find based off my search result, because I'm using a pretty small data set right now while I was testing this. But we can support as high as you'd like in terms of the number of items you get back. And I'm saying, give me the title and the IMDb ID back as metadata with those vectors. So I'm saying, give me the top 3 vectors that are like my input vector, and give me the title and the IMDb back with it. And then I'm going to loop through each of those items returned. And you can see from the metadata, I can build up, I'm actually building up an HTML string here, like a HTML link element based off the IMDb URL and the title. So it's just going to show us a bunch of links with the title of them that link out to the IMDb page, is what this is trying to do. And we have one more function called page handler that's just going to return a static HTML page that powers this to show a little demo. So I've actually deployed this. We have this hooked up with SAM, and I'm going to open source this repo after this talk. I just need to get a few more things cleaned up in here, but we will open source it so you can try this out yourself. And you can definitely try it out yourself right now as well, just based off the blog that's out there. But I'm just have a basic SAM template that's setting up the infrastructure I showed you in the architecture diagram. And I've done a SAM build, SAM deploy into my AWS account. And so now the next thing I'm going to show you is, let me stop sharing my IDE. And I'm actually going to share this UI, which I have going here. And so let me refresh this. Okay, so here I have my UI, and I'm just trying to show a basic search experience here. Can everyone see my the new browser page with the search?
Yes.
Yep, okay. So I'm going to search dogs. Oops. Which is what it's doing in that. Oops. And you can see we get the top 3 results back, and you can see they're all movies around dogs. So we have Fluke, which I've actually never seen, Far From Home, But we can click on it and we can see very quickly that it is a movie about a dog. I don't even have to read the overview to know that that's right on the title here. Same thing, Far From Home, The Adventures of a Yellow Dog. Oops, get off of IMDb. And Lassie, classic movie about a dog. And so this is really cool. So we can search cats. I'm only indexed like a small amount of movies here, and the data set's actually 50,000 movies. So you'll get more. So this isn't like an exhaustive list right now, but I'm just trying to show the point that you can build like a really simple, like essentially text search on top of a set of items in DynamoDB really quickly this way. And so I searched cats, and we got the Jungle Book, the Lion King, the Ref. I'm not sure why that one, we have to read the overview on why that one showed up and got included, but Jungle Book has some description about a cat in here or some wild animals. So it's really powerful, right? And it's pretty flexible, right? Like here you can see the overview just had something about animals in it. And we were able to actually get, let's see, oh, here, kitty. So you can see they had kitty in the overview of the movie, which is why that got included, even though I just searched cat and that's not in the title, because I included that overview in the context of our vector. When we were generating that embedding, kitty was in there and it got flagged as when I searched cat. So I think this is like pretty awesome and pretty fast. And like, I have no VPCs, no clusters, no like idle wasted capacity. I've just completely enabled this on a fully serverless architecture. No OpenSearch, no Elasticsearch either. So like really powerful. I think Dynamo's an awesome database as a NoSQL database, but a lot of times when you want to index stuff and search it in a more flexible way, you have to move to something else. And so this is a really cool alternative to just hook on to the side of your DynamoDB table and enable this type of capability. Any questions? And apologies for my frantic CSS and HTML design coming onto this call. I will clean it up. I'll get our UI designers to take a pass on it as well. Okay, we have some questions.
Question was, are you planning a LangChain vector store integration for this?
Yes, we absolutely are. And actually, because you came to this call, you guys get to see it first. Let me just grab the links. We do. Let me pull up. We actually have it in both JavaScript and Python that you can try out. And actually, we still have some good amount of time, I think. We can actually probably have Michael just run through a quick demo using that as well. Just give me 1 second. Let me share my screen again. We can find it. Oh, here, 1 second. Sorry. I lost my window when I changed screens. 1 sec. Apologies. Here we go. Okay. So yeah, we actually have a Python integration here that you can get up and running, which implements the OpenAI's vector or LangChain's vector store abstraction. And then we have an npm JS module as well, where you can create a Momento Vector Index item that you can plug right into LangChain, so that you can do you can use it right with your LangChain apps. And so I'm not going to steal Michael's thunder. I'll let him show his demo example of these because it's pretty cool.
Oh, thank you, Ellery. So Josh, you're coming in with some great questions here. And short stories, yes, we have the LangChain integration for vector store done. And not only that, but we have caching integrations as well. So you can store your chat history session store in our cache, as well as cache repeated calls to the LLM using the same prompt. So I have a notebook here in case, so we can see a real example. So for those of you that aren't familiar with LangChain, LangChain is an ecosystem that makes it really easy to build applications on top of language models. It abstracts away common elements of the workflow that you encounter when building an application, such as making a prompt that you could reuse, having a turn-by-turn chat with the language model and storing the context, the running history, and so on. But importantly, for our use case, the retrieval workflows. So language models have amazing capabilities where they where they've memorized facts and common knowledge from the data they've been trained on. They have common sense reasoning abilities, and they can produce fluent English. There are limitations, though. Limitations such as the size of the prompt that you can send to it, and also importantly, the knowledge sources that it uses to produce its output for you. So you may have a specific private knowledge source and you only want it to pull information from that. How do you do that? That's where the vector store comes into play. So with that said, with LangChain, you can build these amazing conversational AI agents. And now with Momento Vector Index, you have a really easy to use serverless vector store that you can plug right in. So in both the Python and JavaScript LangChain integration repos that Ellery just pointed you to, we have this example where we're taking a transcript from the State of the Union address from the United States, and we're going to do the whole workflow from loading it from disk, indexing it in a vector store, and then asking questions. So I'll start at the top. Any questions so far before I begin?
I think you should be good.
Yeah, go.
So we're just going to start. So if you were to run this yourself, you would need two API keys, a Momento auth token, because we are using the Momento Vector Index, of course, and an OpenAI key. So I'm just going to go through this. This is just doing some importing libraries that we use throughout the demo. You can go check this out on your own. Okay. So the first thing we do is load the data. With LangChain, there is a large library of data loaders. So I'm loading it from a text file on disk. You could load data from PDFs, from a YouTube video where it can pull the transcript from the video, or it can do speech to text and generate a transcript for you. So you could have a playlist of 20 YouTube videos, and you could say, I'm going to start doing question answering against these YouTube videos right now. But for now, we're using the State of the Union text file, and we're splitting it into smaller chunks. That is snippets of size 1,000 characters. The reason we're doing this is because when we do question answering, we want to find portions of the text that could contain the answer to our question. So when we load this, we get one big document, but then like so. This is the whole transcript, just the first 500 characters. And now we're going to index the chunks into the Momento Vector Index. And so here is our integration in play right here. So Momento Vector Index is a class that implements the LangChain vector store interface. We're setting it up with our Momento configuration, and we're saying we're going to store this data in a Momento Vector Index called State of the Union. Now, adding our data to the index is as easy as calling add documents. This is a LangChain API that takes as input a list of document objects. It'll use the embedding function we specified, OpenAI embeddings, to convert from text to vectors. And then it'll go store those in the Momento Vector Index using the IDs that we've provided. If you don't provide the IDs, it'll generate a UUID behind the scenes and return that to you. passing in IDs yourself is nice, because then if you run this multiple times, you can make sure that you'll overwrite the data instead of just adding new data with a different UUID. So I'm going to do that now. And we're ready to go. So now I'm gonna skip this part. I'm gonna go straight to the question answering. So now we have a vector store that's been populated with our data, and we can now use this in any of the LangChain interfaces that also leverage a vector store. So the simplest one is what's called the retrieval question answering chain, which is a very simple workflow that takes as input a question. Then it consults the vector index, the vector store, to get candidate answers. With the candidate answers, it then takes your question, the candidate answers, and asks the language model, please answer this user's question using these snippets provided as a source for your facts. If it doesn't look promising, then just say, I'm sorry, I don't know the answer to that with the provided information. So that's good now. And so then I can run a question like this. What did the president say about small business? And you can see an answer fully fluent in English that takes into account the data from the vector index. So you can see president mentioned over the last 2 years, this many people applied for a new business. Some other platitudes, and so on and so on. Here's another pointed question. What about credit card fees? You can see president said they've reduced this from that to that. So any questions so far?
No, there was one in chat, but Ellery answered.
Okay, so just to summarize, with the LangChain ecosystem, using Momento is as simple as just adding this extra code to your application. So if you have something set up already where you're loading data and you want to index it, then you just do this and you call add documents, and it's ready to go. You have a search engine set up for you. So this example is ready for you to play with. I'd encourage you to run it on your own, and then look at LangChain at the data loaders and find some data that you're interested in. It could be some websites. So I've tried this, grabbing the URLs of some tech websites where they have gadgets that I like, and I can load that and index it, and then ask questions like, what's the latest on cool smartwatches? And then you can start asking questions like that. That is the demo that I had. I just want to emphasize that this is very little code. Most of this is just boilerplate, like we're checking the environment variables are there, importing the relevant things, and that really you have 3 lines of code to load the data, these 2 statements to index it, and then these 2 statements to set up question answering with the LLM. And you can run this, run the indexing offline, and then have a online agent that can answer people's questions with no headaches about managing infrastructure and scaling and all the goodness that we like from serverless solutions.
Awesome.
Okay. Thank you.
So does anyone have questions? Please send them in the chat and I can read them, or you can raise your hand. But for Ellery and Michael, oh, we got a question here. Then I'll put mine. I have one for you all too. Back to vector index itself, are there size limits for the item metadata or the vector index as a whole?
Yeah, totally. So Josh, we can send you over, if you shoot, we have everyone's emails, right, Chonky, who signed up for this? So
Yep.
we can follow up, Josh, with you specifically, and we'll email you the preview. We have limits on a lot of different bits, but we're very flexible on all of them. So just really would like to work with you. And we can adjust those up or down as needed. I don't know, Michael, if you know at the top of your head what we have those limits defaulted to right now.
I believe the default is 4 megabytes for
Yeah.
the plus the metadata when you're adding it.
Yeah.
So if you think if you have a text application, 4 megabytes of text would be just enormous for a single item. So generally speaking, when you're indexing a vector, then the vector is a fixed size. And so if you're hoping to capture the topics, concepts within some data in just that fixed size vector, then you don't want to just take an entire book and then compress it to a 1000 dimensional vector. It's not going to capture that. That's why I split it up into chunks in my example. So maybe you're asking about what if I have an image that I want, then so you could have some text that's a caption to an image, and then the vector is over the image, and then maybe the metadata you want to include the image itself. So within 4 megabytes, you could do that, although the vector index is not really meant to be a primary data store. So if you have images, for example, that are metadata, you really want to store a link to the image, so that if you have a CDN, then that would be the appropriate way to forward that information to the end user. So that sure, the vector index could tell you here's the URL to the image, and then the user could have that loaded by way of a CDN very quickly.
Yeah. S3 sounds right, Josh. That's just like a pointer. That would definitely be the right way.
Awesome. And another question is the notebook available to share? I think where you were doing the demo, etc.
The LangChain one? Or yeah, those are up in the chat actually already. Let me post them again. Definitely.
Oh yeah, the links above. Yeah.
I'll put them again. Those are available. And this is available. We'll send you our everyone who came, we'll send you our preview PDF about just some information about our vector index, but it's available in US West 2 in our production region. So you can just go and sign up for a token and just start using it with our Python or JS SDKs. So yeah, it's super exciting. I'll put a link to some examples, and we'll have this talk as well open sourced ASAP as well. So
yeah. A quick question. I think like in general, we covered, your example, but what are other good use cases for you and Michael, like for to apply these the words escaping me, to apply what you shared. But what are other common or good use cases that people can keep an eye out for, just, in general for conversation?
Yeah, so the main application is primary search. And so if you have a search bar that you want to help people with, then you could use this. And then with the latest Gen AI technology, you can go from search bar to a conversational UI for the experience. Now, that said, there are other use cases for search that are used by other applications that people may be more familiar with. So recommender systems is a major one. If you have a product catalog and a directory of users, you may want to know, okay, this user has looked at these things, they're interested in these things, and what are some other things in our catalog that we want to suggest to them? Under the hood, that uses search, and actually vector search specifically. And there are other use cases in advertising that would be relevant for e-commerce or a search as well, where you want to recommend advertisements to people. And so that's a little different than recommender systems, but along those lines too.
Awesome. And then thank you, Ellery, for answering the other question in the chat. Any other questions for Ellery and Michael? Seems like we answered them all. And we had quite a few questions in the chat, so this was really awesome. Thank you everyone for engaging. So FYI, we are going to start Lunch and Learns. We have about 5. This is our first one of 5, and we're going to try to host them the same day, same time. We have another one next week. It's on WebSockets, and I believe with Alan Helton from our team. But we'll keep you updated. We'll send anyone who comes to our events, we'll make sure that you are aware of when we're doing the next one. And it's going to be a really exciting series. So thank you, Ellery and Michael, for all your help and work to put this session together. It was awesome. And thanks for everyone who joined, and hope you all have a great rest of your week. Kelsey from my team, she's on right now. She'll be following up post event, and she'll send the documents, links, etc. that both Ellery and Michael shared. And would love feedback. So if you want to email back in thoughts, anything you ideas or anything you thought about the event itself, we'd love to hear from you. So thanks everyone, and have a good rest of your day.